So let's pick up where we left off with the dragster tire here. A dragster tire has a coefficient of friction, a mu of 2.8. Now remember, what often happens here, Brian, people get this, that's a terrible mu, this, mixed up with, don't write this down, that. Friction is the force, mu is not, coefficient of friction is not a force. What are the units for the coefficient of friction? There are none. That's why I didn't put any there. There are none. It's just a ratio of how sticky one object is compared to another object. So don't mix up the coefficient of friction, which is just a number that describes stickiness, and the force of friction, which is mu times the... Okay. A dragster tire has a mu of 2.8. Shouldn't a tire with so much friction slow the dragster down? Using principles of physics, explain why a high coefficient of friction is essential for racing. What did I say, Oliver, the hint was? I know I caught you zoning out. I know my audience. Hint, draw a... What does FBD stand for, folks? Okay, let's draw a free body diagram. There's my dragster. You can draw the car if you want to. I'm not going to. What are the forces acting on it? Get the obvious one. Yes? What else? How do I know? Yeah, it's Newton's first. Is it sinking into the ground? Is it flying into the air? And so it's going to be, in this case, the same size as mg, roughly. What else? Now I got to think about the specific situation. Which way is this dragster accelerating? Let's assume it's accelerating forwards. Which way is forwards? When in doubt, which way do I assume forwards is, just so all our pictures look the same? To the... Okay, so that means, from Newton's first, there has to be a larger force to the right. An unbalanced force that way. What force is that? Now, I don't mind the silence. We're going to puzzle this out. Dylan has a suggestion. If I'm not sure, one of my strategies, and I'm trying to teach you how I figure some of these out, is to put the situation on a different surface, like ice. Ice is my go-to to see if friction is involved here. If this was on ice and the dragster floored it, what would happen? Use your imagination, but what would happen? Cole. So what force do you think is the one that's actually pushing the dragster forward? If it doesn't work on ice anymore, what force must it be? Yeah. Is that what you're going to say, Dylan? Yep. And again, this is a tricky one for people to wrap their brain around. I've been to meetings where I've seen physics teachers drawing pictures, a free body diagram of cars, and they've done this. Don't write this down. They've done gravity, normal force, and they've gone motor, friction. That can't be right. If the motor was what made a car go forward, if you put a car up on blocks so the tires weren't touching the ground and you stepped on the gas, is the motor running? Yes. So should the car go forward? If they were correct, it would have to go forward. It does not. Yet we can agree on that. What makes it go forward? Well, it's the tires. What's really happening between the tires and the road? Friction. It goes back to the very beginning of lesson 5 when we first talked about friction. We said tires push backwards against the road. Emma, forces come in. The road with friction pushes forward. That's where the explanation for this is Newton's third. And friction is what times what? So there's two ways that I can make friction bigger. To increase, that's an arrow pointing up, let me make that a little neater. To increase friction, comma, what? Friction is what times what? So what two things could I increase to increase friction? What two things could I increase? Friction is what times what? Did you just say two things in that equation there? So what two things could I increase? I could increase normal force Why would that be bad? How would I increase the normal force? Make the car heavier. But then since F equals ma, bigger M means I need a bigger force to get a bigger acceleration. So you can say, yuck, we don't want to do that. How else could I increase friction? Friction is what times what? Yeah. How do I increase mu? Sticky tires. And then I said this last day, but I'll repeat myself because you're teenagers. How do they start every drag race? What do they do? Warm up the tires. Yeah, it's a smoke show. People think, oh, it's for the crowd, to psych the crowd up. No, it's to heat the rubber up, because rubber, when it gets sticky, mu goes up. When it gets hot. Sorry, when it gets sticky. When it gets hot, it gets stickier, mu goes up. Is that okay? So we're already starting now to apply just our limited knowledge of Newton's laws to some good engineering for race car driving. Why don't our tires have a coefficient of friction? Because I think I told you, what did I say in the chart? Rubber on dry asphalt, anywhere between 0.4, 0.75. The problem with this, Emma, these tires are going to wear out very fast. If you're a dragster company, you can probably afford new tires every race. We can't. And are we going that fast? We don't need it. It would be overkill. All right, example 7. A force of 120 newtons. I like example 7. I like example 7. I like example 7. Example 7 is a nice question. A force of 120 newtons is needed to push a box along a level road at a steady speed. If the force of gravity on the box is 250 newtons, A, what's the force of friction? B, what's the coefficient of friction? Okay. Any thoughts on how I might want to start this? What I might want to do here? You want to talk me through this? Emily? You know, I will, but there's actually something I would even do even before that. Because I think that's the key. Now, you kind of do that at the same time. So even before I start, now how do I know I'm going to draw a free body diagram? I'm pretty sure there's more than one force in this question, Chloe. How do I know that? They're talking about friction. They're talking about the force of gravity. Okay. So here's the box. What are the forces acting on it? Get the obvious one. And you know what? I'm actually going to write it in. Apparently, they told me it's 250 newtons. What else? Normal force. And you know what? I can tell you now exactly how big the normal force is. Exactly how big is it? Because I don't see any other vertical forces. I think it's 250 newtons. What else? I don't know what that means. And we've typically called the person pushing, we've often called that an applied force, so I'll label it F-app. What else? Is there friction? Which way? Why would that be wrong if I asked you to draw the free body diagram? Or, why would that be wrong if I asked you to draw the free body diagram? How long am I going to draw friction exactly? The same as what? How do I know it has to be the same as F applied? Steady speed. That's why, Emily, I said I would catch that right away as well. So I can even tell you how big friction is. How big is friction? And the reason this is important is I've been repeating myself over and over with poor Tristan. Tristan, friction is what times what? And so I have a lot of students, they go like this. Look up, don't write this down. They go, okay, friction is mu times the normal force, because they haven't read the question carefully, but they see friction. And then they go looking for mu for the coefficient of friction. What's part B asking me to find? you know what? If part B is asking me to find this, I can't use this to find that. And that's also your hint. You got to try something else. I do one more complicated, similar to this, but way more complicated in Physics 12 on one of my tests. And time again, I see kids, wants us to find friction. And they write friction equals mu times the normal force. And I didn't give them mu. And so they panic. I see all sorts, like their pencil vomits on the page or something. They're just desperate. They're writing all sorts of things. I see free body diagrams galore, all sorts of weird stuff. But turns out, with no calculator, how big must friction be exactly? Has to be. The phrase that I often use for questions like this, Misha, is they're so easy that they're tough. Because you're trying to overcomplicate it sometimes. B. Tristan, what's B asking me to find? What symbol is that? Hey, what's mu? I don't know. What's mu with you? It's asking us to find this. So what's the equation that I've been flogging you with today? Friction is? How would I get the mu by itself? What's the normal force doing to the mu? Adding, subtracting, multiplying, or dividing? How will I move the normal force over then? So are you telling me mu equals friction divided by normal force? If you are, yes, that's yet another equation. Don't memorize it. We don't need to. By the way, what's force measured in? So this is newtons divided by newtons. What would newtons divided by newtons be? The newtons would cancel. This is why mu has no units. Tristan, finish this off. How big is the force of friction in this question? And how big is the normal force? I don't know the normal force, but I know it's the same size as mg, which is why I was able to write that there. Yeah. Which is what? It's going to be 12 divided by 25. 0.48? Even? Yep. Units? There are none. 0.48? I don't know. Could be wood over a rough surface. Okay, so there's number 7. Example 8. I like example 8. I like example 8. I like example 8. Example 8 is a nice question. We got a couple more, yeah? Okay. We watched the balloon video last day, yeah? Yeah, cool. A dragster's tires accelerated from rest. I would probably mentally underline the word from rest to a speed of 32 meters per second on a distance of 64 meters. All right. Cool. Nick, what's A asking me to find? I can find the acceleration a bunch of ways. Am I going to use F equals ma and a free body diagram to find acceleration here? Well, I see from rest. I see, what's that 32, by the way? Yeah. You know what? My first inclination then is I'm going to use our pre-Christmas method. I'm going to say, okay. Oh, what's that 64? Is it positive 64 or negative 64? When did we have to make it negative if we were doing something vertically and we were ending up below from where we started? I don't think that's the case here, so I think I can do that. Hey, Nick, I'm looking for an equation that has an A, a VI, a VF, and a D in it. There is one. And if you could do me a favor and get the A by itself. And absolutely, I love the fact that Nick went to his formula sheet. I mean, some of you might have these memorized, but there was no need to, so it's really up to you. We're looking on that row of 4, right? Yeah? Yes. Remember how tough that seemed a couple of months ago, and now it's like, oh, for Pete's sakes, piece of cake. What was VF? 32. Don't forget the squared. Minus 0 squared all over 2 times 64. I might be able to do this in my head, because 32 is 2 to the 5th, so this is really 2 to the 10th. 64 is 2, 4, 8, 16, 32, 64. It's 2 to the 6, 2 to the 7. 8? Double check me. They're all powers of 2, and so I actually used my exponent rules. It's 2 to the 10th divided by 2 to the 7th, which is 2 to the 3rd. It is 8, yeah? No? Yeah? And then, Nick, I would probably go 8.0 to 2 sig figs. If you didn't, I wouldn't take marks off, but it's a habit, right? I noticed the 32 and the 64 to 2 sig figs. Nick, units? Good. Good. Christian, what's B asking me to find? Oh, did you say net? If they say that, I can go straight to F equals MA. No free body, no nothing. Did they give me the mass? Did they give me... Oh, Nick, what did we just calculate? Oh, so did they give me A? No. But could I figure it out? Yeah. Would I feel comfortable now that I've done this with you, not walking you through part A and just jumping straight to part B on a test? Yes. Okay. So it's going to be 540 times 8. Uh, 4,000 plus 300. 4,320. Double check me. 4320 newtons. Cool. Hannah, what's C want me to find? Friction is what times what? So you'll notice, although there's more than one force in here, I didn't sense that I needed to do a free body diagram at the beginning when Nick and I wanted to find A, and I still haven't bothered doing one yet. You don't have to for everything necessarily. Hey Hannah, what's mu? I don't know, what's mu with you? What's mu? So I started out that way, and then I went, yeesh. How else can we figure out friction? This is a job for a free body diagram now. What are the forces acting on this car? I'm going to draw it right here. Get the obvious one. Then? Pointing which way? Mr. Dweck? Isn't it going to be this free body diagram right here? Yeah, okay. Gravity down, normal force up, friction. Who's winning? Loud and proud. Who's losing? It's a trick question. No one. So what's my equation going to be? Normally it's winner minus loser equals MA. Who's winning? So what's my equation going to be? This one, by the way, this one is so easy that it's tough. Who's winning? Minus, who's the loser? It's a trick question. Who's the loser? It's a trick question. No. Who's losing would be pointing that way. What's pointing that way? So who's the loser? Repeat yourself, what you just said. Yeah, so I still mentally did my checklist. I went winner minus nothings. Am I going to write it? No. What does that always equal? What does winner minus loser always equal? Wait. Whoa, you're right. Say it again. Wait. Say it again. Look up. Wait. Say it again. Are you telling me that the friction force here has to be 4,320 newtons, and I maybe could have figured that out just by a good free body diagram and no calculator at all? Because that's where your acceleration is coming from. Is that all right? Now, with real cars, there would also be, don't write this down, a tiny bit of air resistance. Dragsters are pretty minimalistic, though, so let's assume it's nice and aerodynamic and air resistance is near zero. Do you see what I mean by so easy that it's tough? Because now in hindsight, you're going, oh, yeah, friction is the only force in that direction, so friction equals MA, and I already know MA. I hear you. Maggie, what's D want me to find? What did I find in part C? I know where I'm going. Maggie, I'm going to write friction equals mu times the normal force, aren't I? Then what am I going to do? So you and you could have, if you could have done this in your head and jumped straight to saying, I know the coefficient of friction is the force of friction divided by the normal force, I would have said, you go girl. And now what? Divided by, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which one? So I'm going to put mg here, but I'm going to go straight to my calculator now. So, and I am going to need a calculator for this one, I think. Is my calculator going to open? Let's try that again. There we go. 4320 divided by m. Was it 540? Times 9.88. Coefficient of friction of 0.816. One more, we're done. Is that everything? I think it was just up to D. So, could I give you this question on a test, but not ask you A or B or C and go straight to D? I think I would consider that a tough question, Emma, but I'd feel comfortable doing that if I meant it to be one of the tougher questions on the test, because it is technically a four-stepper, although each step is pretty sequential. Emma, what's the first thing you notice in example 9? What's standing out on the picture that makes you go, No, but in that picture, what's looking weird that we normally don't have? Isn't this the weird part? No, there's a vertical. There's another vertical force. Here's what that's going to mean: normal force is not going to be mg. It's not going to be mg. So if you ever see something pushing down or lifting up, don't go friction is mu mg. It won't be. It won't be. Oh, and if it's multiple choice, I will have mu mg as one of your answers. In fact, I'll probably put that as answer A because this drives me cuckoo for Cocoa Puffs crazy. I like example 9. I like example 9. I like example 9. Example 9 is a great question. You ready, Chloe? Good. What do they want us to find? Okay. Did they give me a VI, a VF, a T, or a D? So we're not going to use Nick's from before Christmas. Emma, in fact, you made a comment. You said, "I'm pretty sure we're going to use something." What did you say? Free body diagram. Although I'm going to label the forces right on the picture rather than rewriting everything. So, ready, Chloe? What are the forces acting on this mass? Get the obvious one. Okay, so I'll do gravity down. Are we sinking into the ground like quicksand? Are we flying into like Superman? Now, if that 25 wasn't there, don't write this down, I would make my normal force the same size as mg. But is there another vertical force there? What direction is this vertical force? So does that make the normal force bigger or smaller than mg? Think about it. Makes it bigger? Like that, you're saying? Look at the picture. Does those look balanced to you? I think the normal force now has to cancel out 25 newtons less than mg because someone else is already canceling those out to prevent it from sinking into the ground like quicksand. So the normal force is going to be smaller than gravity. If I was pushing down, that increases the normal force. Chloe, what else? We have that 45 coming from off the page. What's the name that we've given that mystery force from off the page? Applied force. I'll just do that so it stands out. Is there friction in this question? Which way do you think this mass is accelerating? So which way do we think friction is acting? How will we know if we're wrong? remember we did an example where we got a negative acceleration? That's how you know you've guessed wrong. And it's pretty obvious. I got a negative, Mr. Duke. Oh, wrong winner. Redo your free body diagram, start over. All right. Who's winning? Who's losing? What's my equation? Winner minus loser. What does that always equal? MA. What's this question asking me to find? How would I get the A by itself? Okay, let's you know what? Let's do that. So if it's okay with you, I'm going to already go A equals and then divide by M, and you said the F applied drops down like a domino minus, Tristan, friction is what times what? Mu times the normal force. And I don't know the normal force, and this one's going to be a bit yuckier. So I'm going to actually do the normal force off on the right here in the margins, sort of. Are we sinking into the ground like quicksand? Are we flying at you like Superman? What that really means is everything down has to equal everything. What is everything down in my free body diagram? Has to cancel out, has to equal. What's everything up? And would suggest plus, yes? 25. How would I get the normal force by itself? So you're telling me equals mg minus 25? I totally agree. Now, if you wanted to, Matteo, I would have no problem if you plugged in m, if you plugged in g, and you went minus 25. You got a decimal. I'm not going to evaluate that. What I'm going to say is, Chloe, can you read this to me right here, please? Normal force equals, what's the normal force the same as? Wherever I see a normal force, what can I replace it with in brackets? So I'm going to go like this. A equals F applied minus mu bracket mg minus 25. All over M. Do a quick check. Do I know everything? Do I know F applied? Do I know mu? Do I know M? Do I know G? 9.8. Do I know M? Hey, good. We figured out everything that was missing. Now we've got it to the plug and chug stage. I've scrolled down. What was F applied? 45 minus, hey, what's mu? I don't know. What's mu with you? What's mu? 0.36? 0.36. I usually go to a square bracket here because it's going to be a bracket inside of a bracket and it helps you track things better. What was M? I've scrolled down. It was 5 point something, wasn't it? 5.8. I usually write a times 9.8. You could do this. Bracket, 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 bracket. I just find it's too many brackets to start keeping track of, and I get confused, and I know this time I want those two numbers to multiply, so I usually do that. Minus 25, close off that. And the mass was 5.8. This is one all of you maybe want to practice with me on your calculator. How would I type this in? Chloe, is this a fraction? Is there more than one thing on the top? Starting to see why I did all those rants before Christmas, by the way. So we're going to go open a bracket. 45, take away, 0.36. And then I got to open another bracket. Now, on some of your calculators, you might have to go times and then open the bracket. Some of you can probably just put a bracket there. And I'm going to type 5.8 times 9.8, take away 25. I think that's the easiest to track what's going on. I got to close off that bracket, and I got to close off the top. So there's two closed brackets. Divided by, is there more than one thing on the bottom? Go ahead and brackets. 5.8. And I get 5.78. Anybody else? Yeah? Chloe, units, it's an acceleration. Yep. So I would consider this fair game. Before we go further, Could I reverse this question? In this question, I gave you mu and said find A. What if on this line right here, I gave you A and I said find mu? Instead of dividing this m, you would have left it at the front, and you would have got the mu by itself. What's right in front of the mu? A minus sign, we would do the swappy dance, and then divide by the normal force. I don't know the normal force. Oh, but look, we can figure out the normal force. In other words, I'm trying to teach you a method, Maggie, so if I show you how to solve a question one way, we can also just reverse the question. We can figure out any information that whatever engineering situation we're looking at requires. Is that okay? So, I already assigned 1, 2, 3, 4, 5, 6, and 7. We can also handle number 8. Number 9. Emma, in both 8 and 9, can you see there's an extra vertical force? I'm telling you right now, Tristan, the normal force is not going to be mg. You're going to have to do some off in the margin calculating to get the normal force. And number 10, same dealio. I got a cool video to show you though.